Hi, everybody. Sorry I'm out today, but I figured I would leave you a video lesson to watch so that you don't miss any work through the workbook and lessons because we do have a pretty tight crunch to the end of the marking period. So here are the answers to your homework from last night. I do want to make sure that you have a chance to review these. If you have any questions on 28 to 30, please let me know when I come back tomorrow. Here's question 3 and 4. Here's question 5 and 6. And please, at any point, feel free to pause the video and re-watch if you need to. And here is the answers for question 7. All right, so reminders of upcoming things. So we have no school on the 15th. End of Unit 3 test with no retakes and 50 points is on the 24th. End of the semester is the 26th, as well as your marking period 2 progress check. And then there's no school on the 29th. You do have homework tonight. Your homework is pages 35 to 37. Please make sure you are getting this done. And you are going to have a cool down that you are turning in at the end of class today. So you're more than welcome to watch this video as many times, rewind it, pause it, whatever you need to do. But please make sure that you get your cool down turned in by the end of class and hand it to the sub. Your warm up is on page 31. And there, it's a notice and wonder. So you have triangle ABC with midpoints L, M, and N. Take a minute to pause the video and write down a couple of things that you notice and a couple of things that you wonder. Thank you for taking a minute to pause the video. So a couple of things that I'm hoping you noticed. I'm hoping that you saw that AM is congruent to MB. I'm hoping that you saw that BL is congruent to LC, and that both of those statements make sense because M is the midpoint of AB, so it's going to divide our line in two. And L is the midpoint of BC, so it's also going to divide that line in two. And again, N is the midpoint of AC, so it divides the line into two equal parts. A couple of things that I'm thinking you may be wondering, maybe you're not, I'm not sure, but are these triangles in the middle, these four smaller triangles, are they congruent? Or are they similar? Or are they similar to the big triangle ABC? Or what is the relationship between segment MN and segment BC if there is one? Or segment NL and segment AB. So there's a lot of things that we can notice and wonder about this shape. So with those things in mind, we're going to skip ahead to page 32. And I know there's a lot on this slide, but it's more of a conversation piece. So I'm going to be talking about a couple of things, and then I'm hoping you are going to take a minute to turn to your table mate and re-explain it to them. Because if you can explain it to somebody else, then you understand it more. And that's the point of this activity. Hopefully you're watching this with one of your table mates, so then you guys can kind of bounce ideas off of each other. But either way, try to explain it to somebody else so that you can put it into your own words. So again, here's triangle ABC, same triangle that we just had. We just took point L off of side CB. So you just see two triangles. You see little triangle here, AMN, and big triangle ABC. So points M and N are the midpoints of two sides. Convince yourself triangle ABC is a dilation of triangle AM. It should be an N there, not a D. What is the center of dilation and what is the scale factor? So when I look at these two triangles, I notice that they have these two parts are congruent. I notice these two parts are congruent, but I also notice that triangle AMN and triangle ABC share a letter, which means they share an angle. And just like with our triangles before, when we shared sides, we can share an angle, and these angles are considered congruent because of the reflexive property. It's the same angle in both of our shapes. If we have a shared angle like this, then this point or the vertex of this angle becomes our center of dilation. So everything is coming out through or starting at A and going through the other points. So our center of dilation is point A. And the scale factor, when we look at our triangles, we're really comparing the length of AB, which is this side, to AM right here. We see that AM has the same length as MB, which means that AB is going to be 2 times the length of our original triangle AM. And we can also see that over here with AC. AC has 2 segments, AN and NC, making up this side of our triangle. And the segments are congruent. So we have 2 times the length of AN is equal to the length of this segment. So our scale factor ends up being 2. Now I want you to take a minute and pause the video again and convince your partner or somebody sitting at your table with you that triangle ABC is a dilation of triangle AMN with the center and scale factor you found. So I want you to take a minute and explain to them why the scale factor is 2, why is point A the center of dilation. Pause the video and explain now, please. Thank you for taking a minute to make that learning make sense for you and explain it to somebody else. Part 3, with your partner, check the definition of dilation and make sure both of you could convince a skeptic that ABC definitely fits the definition of dilation. One place you can find your definition of dilation is on page 121 in the back of your student workbook. The definition of a dilation is a dilation with a center P and a positive scale factor of K takes a point A along the ray PA to another point whose distance is K times farther away from P than A is. So what that's telling you is you're going from your center of dilation to a certain point for your pre-image, and then you're taking the length or the distance between A and M, and you're multiplying that distance by some number to get the length of AB, which we did. We multiplied AM by 2, and over here we multiplied AN by 2 to find the length of AC. So that fits our definition of dilation because we're using a scale factor, or we're multiplying the length of our original image by the same number. Now that I've said that, I want you to turn to your partner and convince them that segment BC is twice as long as segment MN. And then I would like you to take a couple of minutes with them to also write a proof that BC equals 2MN and convince a skeptic. So take a couple of minutes in your workbook and to write out an explanation as to why BC is equal to 2 times the length of MN. Thank you for pausing the video and taking a minute to do that. So on this page, I know you have a little bit, not as much space in your workbook, but I wanted to make sure that I had enough space to write out a valid explanation or an easy to follow explanation. So we know already, and I'm going to write this as we go, we know angle A is congruent to angle A. We know that angle ANM is congruent to angle C. This angle is congruent to here. And we also know that angle AMN is congruent to angle B. We know this because we know we've performed a dilation. We've proven that we've formed a dilation. Because triangle ABC is a dilation of triangle AMN. Okay, so now that we've shown that all of our angles are congruent, we can say that our triangles are similar. And we also know that our scale factor for this specific problem is 2. So we know the scale factor is 2 by comparing a n to a c and a m to a b. Therefore, if we're applying a scale factor of 2, in order to find the length of BC, we're going to compare the last side of our triangle, our bigger triangle, to the last side of our original triangle. Therefore, when we apply the scale factor to mn, we find that BC is equal to 2 times the length of mn. So if we're expanding this by 2, we're going to end up getting in the same place as BC is. Take a minute to review that by yourself or with a partner to make it make more sense to you, and feel free to change the words so that they're really your words instead of mine. Thank you for taking a minute to make it make sense to you. Let's go to activity 5.3. Here is triangle ABC again. M is 2/3 of the way from A to B, and N is 2/3 of the way from A to C. So to me, that means, without even looking at what this is saying or what it's asking me, I'm going to write down my center of dilation is point A. And I also know what my scale factor is. My scale factor is 2/3, which means if my scale factor is 2/3, my image is getting smaller than my pre-image. So my image is actually AMN, because that's the smaller triangle of the two, and my scale factor shows me my image is smaller than my pre-image. All right, so what can you say about segment MN, this one, compared to segment BC? The first thing that comes to my mind is that MN and BC are parallel. We talked about this on Friday with our dilations. When we make a dilation, if they're coming from a center point and we're dilating it and the lines happen to be collinear, then we're going to have parallel lines. We know with our dilation, these two angles are congruent. And if I forget about this side and just pay attention to MN and BC cut by a transversal here, these two angles are called corresponding angles. And if corresponding angles are congruent, our two lines have to be parallel. So MN is parallel to BC because corresponding angles on a transversal are congruent. Okay, so that means these two lines, or these two segments, are going to be parallel. The other thing that it makes me realize is BC is going to, or MN is going to be multiplied by, or is equal to 2/3 times BC. because we're multiplying our scale factor on our original image. If you look back at this one, the reason why BC was equal to 2M is because our original triangle was AMN and our dilated triangle was ABC. For this example, our scale factor tells us the image is the smaller triangle, so I have to apply the scale factor to the pre-image. So I'm applying the scale factor to segment BC because that's in the pre-image triangle. Multiply that by 2/3, and that's going to tell me the length of MN. So MN is equal to 2/3 times BC because we multiply the scale factor by the original figure's length. Last piece for today is the "Are you ready for more?" on the bottom of page 33. This one I like because we haven't talked about negative scale factors, and they're an interesting, something interesting happens. I kind of like it, so I wanted to share it with you guys. So we're going to dilate triangle DEF using a scale factor of -1 and center at F. So the first thing I'm going to do is come down here to F, and I'm going to put a special color on F so that I remember that that's the center of my dilation. The other thing I'm going to look at, there's two different factors to this. We have a negative and we have the number 1. So this number 1, let's talk about this first. This number 1 means that the size of our shape is not going to change. Which we know from rigid transformations, we were always working with a scale factor of 1 because our size didn't change. And we've had a couple of questions about that in cool downs or in your homework. The negative actually makes it so instead of going from the center to your point and continuing through to find your image, you're actually going to go in the opposite direction. So this time we're going to go from our original point through our center and continue in the opposite direction. So when I'm thinking about finding point D prime, if I want to find D prime, I'm going to start by making a line that goes through D and through F and then continues on this way. And I'm going to put a point that is going to be equal distance from F to D because this distance stays the same because my scale factor is 1. So again, I'm not going to measure it because you guys have seen how frustrating the ruler is on this. We're going to say, rough guesstimate, that this is D prime. So this segment is the same length as that segment. Because our scale factor really is 1, we're just going in the opposite direction. Now if I wanted to find E prime, I'm going to start at E, and I'm going to extend through F, to the center of my dilation, in the opposite direction. And then again, our scale factor is 1, so this segment is about yay long, guesstimate. So here is about where E prime is, and if I connect those two, there's the other end of our triangle. This side is congruent to this side. So how does, I just answered that by what I was showing you. So how does DF compare to F or DF prime? So DF and DF prime are actually going to be the same size or are congruent. DF is congruent to DF prime because our scale factor is 1. We just have it on the opposite side of the center of our dilation. Are E, F, and E prime collinear? Explain or show your reasoning. So collinear means together on a line. So E, F, and E prime. Yes. Anytime you have a dilation, your original image, your center of dilation, and your image point are always on the same line. It doesn't matter if you have a positive or a negative dilation. The negative just means you're going in the opposite direction. Yes, because a dilation has the original image the center and the image point connected through a line or on a line. Whether you have a positive or a negative scale factor, this is always true. They're always going to be collinear if they're corresponding parts. All right, so now that you have seen all of the dilation information and information about triangles and midsegments, I want you to take some time and do your cool down. If you do not have the cool down in front of you, then please ask the substitute for the cool down. Once you have finished your cool down, I would recommend putting this theorem in your student workbook. Either add it to page 34. I know some of you are putting definitions in the front cover of your workbook. Put it on a random page in lesson 5. It doesn't matter to me. I just really want you to write this down because I think it's important for you to have. A theorem to add to your notes. If a line divides two sides of a triangle proportionally, the line must be parallel to the third side of the triangle. Proportionally means that there's a scale factor involved. So please take some time and write that down and then complete your cool down and turn that in before the bell rings. Reminder, your homework that I will be checking tomorrow on Tuesday is 35 to page 36.